Welcome to aminacademy.com. In mathematical economics, let us discuss about some solving problem regarding first order partial derivatives. Use the quotient rule to find the partial derivatives of the following functions. Here, z is 8x over 6y minus 5x. Here, the function is with two variables x and y. We have to find partial derivatives with respect to x and y separately. First, dou z by dou x. That means derivative of partial derivative of z with respect to x. Quotient rule is first denominator square, that is 6y minus 5x the square. Then that will come here 6y minus 5x, that is v, into du. Differential of 8x with respect to x is 8 minus then this function 6y then 8x, that is function x with derivative of the denominator with respect to x. 6y derivative is 0, minus 5x is minus 5, which is equal 6y into 8 is 48y minus 40x plus 40x over 6y minus 5x the square. Here minus 40x plus 40x is cut, therefore we have 48y over 6y minus 5x the square. Next one, the same we have to do with respect to y. Therefore here z is x 8x over 6y minus 5x. Therefore here dou z by dou y. Here quotient rule, first 6y minus 5x the square and the same function 6y minus 5x into derivative of 8x. 8x derivative with respect to y is 0 because partial derivatives minus then 8x, that is u, over derivative of the denominator with respect to y is 6. So we have 6y minus 5x the square. This becomes 0. First part is 0, then second minus 48x. This is dou z by dou y. We can write this as fy also. This we can say fx. Next question, look at here. This x square over y, x square minus y square over 3x plus 2y, that is dou z by dou x, which means fx. Here equal square of denominator, that is v square, 3x plus 2y the whole square, and 3x minus 2y, derivative of numerator x square minus y square in terms of with respect to x is 2x minus, then after that this function, that is x square minus y square over into, then denominator's derivative with respect to x is 3. Then we have 3x into 2x is 6x square minus 4xy minus 3x square minus minus plus 3y square over 3x plus 2y square, which is further equal. Then 6x square minus 3x square is x square and minus 4xy plus 3y square over 3x 2y the square. Next, same will do this quotient rule with respect to y, that is, look at here, dou y by dou y by dou z by dou y equal same denominator square, that is 3x plus 2y the square. Next, derivative of 3x plus 2y with respect to y is, that is first this function 3x plus 2y, that is numerator, denominator into derivative of 3x plus 2y with respect to y is 2. Then denominator 3x plus 2y whole square into that function 3x plus 2y and derivative of minus 2y here, minus, then minus, and x square minus y square and derivative of derivative of 3x minus plus 2y with respect to y is into 2. So which is equal 3x into minus 2y is minus 6xy plus 2y minus 2y is minus 4y square. Here x square into 2 minus 2x square plus 2y square over 3x plus 2y the square equal. Here minus 6xy, here minus 4y square, minus 4y square plus 2y square is minus 2y square, minus 2y square minus 2x square over 3x plus 2y the square. Next is find the first order partial derivatives by using a generalized power rule. Here Z is 8x squared plus 3y squared whole cube. First, here, dou Z by dou x. First, power rule use. Power rule is 3 comes front, 3 into 8x squared plus 3y squared 2, because reduce the power by 1, 3 minus 1 is 2, into derivative of inner function with respect to x. 8x squared derivative is 16x and 3y squared derivative is 0. So which is equal 3 into 16 is 48 x into 8x squared plus 3y squared. That means 16x is multiplied with 3 is 48x into this one. Here, this is a dou z by dou x. Similarly, dou z by dou y is same, that power come front, that is 3 comes front into derivative into the function 8x squared plus 3y squared into the derivative of 8x squared plus 3y squared in term with respect to y is 6y. Now which is equal 6 into 3 is 18y into 8x squared plus 3y squared. This is dou z by dou y. Next is z equal 3x plus 11y whole cube over 2x plus 6y. Here, the combination of power rule and quotient rule. This is first, dou z by dou x is equal, first denominator square, 2x plus 6y, the square. Then the function 2x plus 6y into that derivative of the numerator, that is first power come front 3 into 3x plus 11y the square, then into derivative of inner function with respect to x is 3, then minus, then after that derivative of numerator, this one is 3x 11y the cube, and derivative of that denominator with respect to x is into 2. Look at your one more time. Here v square, then v into du here, du and minus u dv, then which is equal, here 3 into 3 is 9 into 2x plus 6y into 3x plus 11y minus 2 into 3x plus 11y the cube over 2x plus 6y the square. This is for dou z by dou x. If you open this all and here on denominator, we can simplify. Then next one, dou z by dou y. A similar way, here 2x plus 6y the square, then 2x plus 6y, that is v square, v into u, that is v du. Du is what? With respect to y is 3x plus 3 into 3x plus 11y 3 into 3x plus 11y y the square, and the inner derivative is this is 11 here. Inner derivative with respect to y is 11 minus then derivative of the denominator, that is dv. Dv means what? Then first the numerator is 3x plus 11y the cube, and dv with respect to y is 6, which is equal 3 into 11 is 33, 2x plus 6y, 3x plus 11y the square, minus 6 into 3x plus 11y the cube over 2x plus 6y the square. Here, so far we discussed about some first order partial derivatives with function having quotient rule. By using quotient rule and power rule we have done. Please subscribe our YouTube channel.